Hello and welcome back to our lecture on how to make particle system and what all of these particle system variables and parameters mean. So next thing I'm gonna show you is gonna be velocity over lifetime. Well, we're not gonna use velocity over lifetime exactly. We're gonna limit velocity over lifetime. So we have limited velocity over some period. So we're gonna get random between two curves, and we're gonna set limit this curve, and we're gonna write this so it can look more like explosion. And we need to select speed and set it to maybe 30, and so we have some explosion like effect. So we're gonna decrease this right now here, and this actually looks like something we already want. So depending on how fast you want your explosion to happen, you're gonna add these parameters here. So if I set, for example, 50, it's gonna happen really fast. And if I set, for example, 150, it's gonna be so fast. And for example, I want it to be now 50. So we actually have this starting pattern of explosion that happens right here. And the most important thing here is you need to set a random between two curves, so you can be more realistic and it can look real good. I'm sorry. And right now you can inherit velocity also, which you need to set parameters also for that. And you can also set any force over lifetime, for example, any force that affects any axis right here and at any space. And you can also set any color over lifetime, so which color over lifetime is really good, and it's widely used when it comes to explosions. So right now we're gonna edit color of lifetime, and we're gonna set a color from some gradient. First, we have this white gradient, and this white gradient represents our white particle system that we have right here. So we're gonna change this particle system to some certain color, and we're gonna click this white color here, and right here we have presets. So we have white preset, we have some orangey preset, and any preset that we have here. So we're gonna select this first one, and we have some starting color, which is, I don't know what is this, cream color or coffee, I don't know. And we're gonna change it to a maybe darker orange to have some more explosion looks. So we're gonna change this color to here. But what is also important that you can edit this gradient, so where the white color starts and how it starts. So by sliding this button here, you can also edit the amount of orange color and when it changes to the white, etc. So this is pretty good parameter, and it's widely used when it comes to making of explosion. So you can see how it looks right now. It's most of the time orange, but at the end, when it should end, it also appears to be white. And you have also color by speed, so it can change any color when it reaches a certain speed. And it also works in the same principle as this. You can choose gradient, and you can choose color from what speed range to what speed range. For example, if we have speed from 5 to 20, it can change during that speed some color. It is good to use when you have certain explosion that actually changes color over time. So we can change maybe to a certain red or anything, you know, that you want. It can be, I don't know, maybe red, and it can go reddish from the middle, from when it's slow, it's like red, because we have 0 parameter set here, etc. And also we have size over lifetime. I usually use size over lifetime with curve, and I set random between two curves, and I actually set the speed to be like for 3, for example. And I did it this way. I set it to go from maybe 1 to maybe 2.8. So all of these particles are going to be randomized from the size which we see right here, which is 1 point, I don't know, maybe 4 to maybe 3. And all of these particles are now randomized, and it looks much more better. And in any way that you want to combine it, you can use it right here in any size. So you can also set size by speed when it reaches a certain speed that it becomes smaller. You can use this when you have maybe a meteorite falling from the sky, and during some period it becomes much smaller and smaller. You can make anything, like literally anything. You can also make one single explosion here with one single effect. Maybe you can make just one particle bolt, for example, which is falling from the sky or something like that, and may reduce it over time, give it certain effect, etc. And we have also rotation over lifetime. I like to use a rotation over lifetime, for example, to set it between two constants, and I set it from -720, so you can have many splits over lifetime and look much more realistic. So minus 7, oh, and go plus 7 maybe. Okay, 720 minus 720. And it also, actually, if you have any sprite bound to this, it's gonna rotate many full splits, and it's gonna look much more realistic and better in terms of explosion. So we have also rotation by speed. It seems like rotation over lifetime. It just rotates over certain speed when it reaches any speed, and etc. You can also edit noise, but be careful when editing noise, because noise is actually very demanding when it comes to memory in computer. For example, I'm going to show you right now. My computer is probably gonna stop for a second, because you see Unity stopping, because noise takes much memory, and it's gonna look like this. It's gonna look like, give it some butterfly effect on any string that you want to increase in frequency. It's gonna affect your computer. So make sure that you optimize your particle to be good for the game, so it won't have any crashes or any difficulties by emitting later. So right now I'm gonna turn off this noise, and you have also collision. You can set any collision that you want to your particle system, and you have any trigger, what it triggers, what should it do, what should it do, inside, outside, exit. But you need to set the collider first to have any trigger. So of course, because it cannot trigger if it doesn't exist like object. So also you can do sub-emitters. Well, sub-emitters is something I will explain in the lecture when making an explosion in this certain course. And it is when, for example, sub-emitter of this could be some kind of rocks, and sub-emitters is some particle that is immediately followed by this particle that we have right now, and it is immediate action, immediate product that happens after this particle. So I said before that sub-emitters may be stoned, because they actually explode and go around with all these particles, and which happens when these particles occur. And sub-emitters are pretty much a good thing, because they allow you to do anything, but basically anything, to make any sub-particle of your existing particle that you made. And also you have texture, sheet, animation, lights. You can edit any light that you want your particle system to have. Also you have trails, which is overall the trail of the particle system you have, if it's gonna leave any trail at all. So right now our trail is some magnetic color or etc. But you can leave your trail to be maybe white, or if you want to make any effect, for example, like stereo effect, to have some shiny trail behind it, you can edit it and make your material to set your trail. So right now I'm not gonna set any trail. And you can also, the most important thing right now is renderer. In the renderer function here, in this render bar, you can edit your own image. You can edit your own sprite to be material and actually bind it here. And when it's being bound here, you have your own image displayed here as a material in your particle system. And for example, if you want it to be sparks, if you wanted this to be sparky, we would just implement spark material here, and we would put it in default particle which we have right now, and it would go to anything. If I wanted to be sparky, I would go to stretched. I would switch render mode to stretched, and if I want to make sparks, I would set this right now. I would set simulation speed to 20. So you see what happens here. We have many sparks going on, and that's it. That's pretty much what I wanted to show in this tutorial. Thank you very much for watching, and see you in the next lecture.